So in this lesson, we are going to look at this idea of what's called scientific notation. So scientific notation. So basically, like, what is scientific notation? So within maths and within the fields of, for example, chemistry and physics, we come across like very big numbers. So for example, like this number here. And we also come across very small numbers like this number here. So if we think about like what are very, very big numbers, well, if we were to be counting, for example, maybe the number of atoms. So number of atoms, for example, in a sample. So this would be a very, very big number. For example, if we had a sample of salt, let's say, so this is our sample, and we were counting the number of atoms, we're going to have this massive number. We're going to have a huge number. So just to kind of put it into context, if you were to take this full stop here, for example, within that full stop, the number of atoms that would fit in that full stop would be equivalent to all of the grains of sand on the entire planet. So if you were to count all the grains of sand on the entire planet, they would fit into a space that's as small as that dot there. So in order to be able, for scientists or chemists to be able to use numbers, so use these massive numbers, they have to have a system to be able to do it. So if you were to try and do calculations using this massive number here, for example, it would be very difficult and cumbersome, and you'd probably run out of space on the page. So we have to have some way of shortening this down and being able to retain the information and work with these very, very big numbers. And likewise then as well, on the other extreme, we have very small numbers. So for example, if you were to talk about, let's say, the size of a coronavirus. So if we take the width of a human hair, so imagine this was the width of a human hair. So the human hair, something like that. So the width of a human hair, and if we were to take the coronavirus, so roughly about 1 million coronaviruses would fit across the width of a human hair. So if I asked you, for example, to measure the width of a coronavirus, so it's this tiny, you're going to have this really, really small number. And it'd be something like much even smaller than this. So again, we need to have, so this is a very small number. So in order to be able to use small numbers, we need to have some way at working with really big and really small numbers. And that's where this idea of scientific notation comes in. So we need to be comfortable with taking big numbers and writing them into scientific notation, and then understanding like the scientific notation and what it means and what it looks like. So basically what you could be asked to do in your junior cert in relation to scientific notation, you could be asked to take a big number like this and to write it in this form here. So this is the standard scientific notation form. So it's a multiplied by 10 to the power of n, and then you'd have this where a, okay, where this number here is a number between 1 and 10. So it's basically a is less than or equal to 1, and a is less than or equal to 10. So basically you want to write it in this form where this part of the scientific notation, a is a number between 1 and 10, and then it's multiplied by 10 to the power of n. So how do we do that? So if we take this number here, so let's work with this and see how we can go about taking this big number and turning it into a number that's in this form here. So basically what we do is we start at the end and we count our way back. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we're taking our decimal place where it would be here and we're moving it up to here. So between the 3 and the 4. So that gives us a number 3.47. And if I just write this down here, so we'll say this is question 1. So if we write this number down here, so it's 3.47. Okay, so that's a number that's between. So it's following this rule here. So it's a number between 1 and 10, so 3.47, and then it's going to be in this form, so it's multiplied by 10, and then to the power, this n is going to be the number of jumps that you've had to make in order to get it to this place here. Okay, so if we take this, so we've made, so let's say, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so we've made 15 jumps. Okay, so, and we can look at it from this way as well. Okay, so we can say, so it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so n in this case is going to be equal to 15. So basically n, the number, it's going to be the number of places that you have to make the decimal place move in order for it to be in a position that gives you a number between 1 and 10. So the number is 3.47, which is between 1 and 10. So it's to the power of 15. And this is positive 15, okay? So basically what this here represents, this represents this big number here. And this is the number in scientific notation. So again, it's in the standard form. So we have A, so this is the A part, multiplied by 10 to the power of n. So n is this part here, and then A is this part here. And then this is the 10. So how do we figure out what number we put up here? Well, we have to look at how many times we have to move the decimal place in order to get a number between 1 and 10. And that's what that means. So again, if you have a number that's like this, in order to change it back to standard form, you'd move the decimal place to the right. Okay, so that's the first scientific notation. So you're taking a very big number and you're turning it into a more manageable number like this here. So the next one then is if we want to take a small number and turn it into scientific notation. So again, we use the same principle. So we want to write it in this standard form here. So what we do is we take this and we move it until we get to a point where we have a number, the A number, that's between 1 and 10. So again, we move our decimal place and we count the number of places we move. So we go 1, 2, 3, 4, and then if we stop here, so this is 5. So now notice here that we have this number 1.274. So that's the number A, for example, in this standard form. So it's going to be 1.274. And then it's multiplied by 10 to the power of n, and n is the number of positions you've had to move. So we've had to go 1, 2, 3, 4, 1, 2, 3, 4, 5. We've had to move 5 spaces. Now the difference with this is that this is going to be a negative, so it's negative 5. Okay, so that basically means when you're writing a small number in scientific notation, the n part here, or the power that you're raising it to, will be a negative number. When you're taking a big number and turning it into scientific notation, the number up here, n, will be a positive number. So that is scientific notation. So that's how you take a big number and turn it into its scientific notation form, and how you take a small number and turn it into its scientific notation form.